In this video, we are going to solve question number 3 of exercise 1.3. The question is, prove that the following are irrationals. Over here, the first subpart is 1 upon root 2. So we have to prove that 1 upon root 2 is an irrational number. So we will start first of all with assuming 1 upon root 2 as rational number. So let's write down, let 1 by root 2 be a rational number. So definitely 1 upon root 2 can be written in this form, p by q. Now over here, p as well as q, they both should not be equal to 0. P should not be equal to 0 as well as q should not be equal to 0. Now, why is it so? Because over here we will take the reciprocal. So, when we will take the reciprocal, it will become q upon p, right? And on the left hand side, you will get root 2 upon 1. So, which can be written as root 2 is equals to q upon p. So, clearly we can see here that left hand side is root 2, which is an irrational number. Left hand side is irrational. And right hand side is q by p. That's why we have taken p should also not be equal to 0. P is not equal to 0. So therefore here q upon p, which is on right hand side, that is rational. So what did we observe? That left hand side we have an irrational number and on the right hand side we have rational number, right? So here it contradicts because rational number cannot be equal to irrational. Rational number cannot be equal to irrational. So over here we can see that a contradiction has arisen. So we will write down this contradiction has arisen due to our wrong assumption. That 1 by root 2 is rational. So if this is wrong assumption, then what should be the correct one? The correct statement should be, it implies 1 upon root 2 is irrational. So over here also we have applied the method of contradiction. We assumed first of all that 1 upon root 2 is rational number, and based on that we got left hand side to be irrational and right hand side to be rational number. Now left hand side has to be equal to right hand side, right? But in this case, in our case, we got left hand side to be irrational number and right hand side to be rational number. So which contradicts, right? Rational number cannot be equal to irrational number, and this contradiction has arisen due to our wrong assumption that 1 upon root 2 is rational number. So which implies that definitely 1 by root 2 is irrational number. Now this is the second subpart of question number 3. So here also we'll assume first of all, let 7 root 5 be a rational number. Which implies that we can write down 7 root 5 in the form of p by q, where q is not equal to 0. Now, keep root 5 on the left hand side as it is and take 7 to the right hand side. So we will write down p upon 7q. Now again we are at the same position here, root 5 is irrational number, and p upon 7 cube is rational number. So what did we get? The left hand side is irrational number, and right hand side over here, RHS, is rational number. Now we know that rational number cannot be equal to irrational number, right? So we will be writing irrational number cannot be equal to rational number. There is a contradiction here. Left hand side is something and right hand side is something else, and this contradiction has arisen due to our wrong assumption. So we will write down this contradiction has arisen due to our wrong assumption. That 7 root 5 is rational number. If this assumption is wrong, what should be the right thing? It implies 7 root 5 is irrational number. Now this is the third subpart of question number 3, 6 plus root 2. Here we have to prove that 6 plus root 2 is irrational. So again we will follow the same procedure. We will write down that 6 plus root 2 be rational number, which implies that we can write it down in the form of 6 plus root 2 is equals to p upon q, where q is not equal to 0. Now again keep root 2 as it is on the left hand side and take 6 on the right hand side. P upon q minus 6. On taking the LCM we will get p minus 6q upon q, and on the left hand side root 2. So what did we observe here? Definitely root 2 is irrational number. And p minus 6q upon q is a rational number. So left hand side over here is irrational, and right hand side is rational number. Now there is a contradiction over here, right? Left hand side is irrational number and right hand side is rational number. So why is this contradiction? Irrational number cannot be equal to rational number. Irrational number cannot be equal to rational number. This contradiction has arisen due to our wrong assumption. That 6 plus root 2 is rational number. So if this assumption is wrong, that 6 plus root 2 is rational number, what is the other way around? Definitely 6 plus root 2 is irrational number.